Thanks for pointing out the controversial discussions which are already happening in the media about statements that it would cost trillions of dollars for the energy transition and we should burn more oil and gas. So we will now start right away with the complete opposite view of this. We hear the first keynote, the road to 100% renewables in Asia, solar and storage playing a critical role in the energy transition journey. And we have no one no less than Professor Andrew Blakers from the Australian National University, one of the pioneers and one of the thought leaders in solar photovoltaics. Andrew, please.
Storage is a solved problem. There's nothing to invent. We've got everything we need. It's the cheapest energy in history. Game over. This is the amount of solar, wind and other generation technologies installed each year from 2020 through 2024. The blue bar 2024 is an estimate. You can't even see nuclear. It's absent. It actually went backwards last year by 2 gigawatts. All of the other renewables, hopeless. Bit of hydro, bit of coal, bit of gas. Some wind. It's solar. Solar won. It's just unarguable. Looking at generation at a global level, blue is hydro, growing slowly. Black is nuclear, going nowhere. And yellow is solar, plus wind, past hydro in past nuclear in 2020, has now passed hydro. Will catch coal and gas well before 2030. It's game over. I can understand why the oil industry is concerned. They lost. This is what's happening in Australia, a global pathfinder. Black is coal and gas. Blue is hydro. It's going sideways. We stopped building hydro about 20 years ago. Green is solar and wind. Green will be at 75%. Solar and wind will be at 75% in 2030. That's 6 years away. Hydro will still be at 7%. Fossil fuels will be down at 18% and declining. This is government policy backed up by government policy initiatives that will ensure this, provided there's not a change of government at the next election in May. If there's not a change of government, the policies will be locked in by long-term contracts, and that will be it for Australia. But even if there is a change of government, it only puts the transition back a year or 3. It's just so compelling in Australia that solar and wind won the energy race. So it's not widely understood how very little land is required for 100% renewables. So complete global decarbonisation for affluent people, fully decarbonised by electrification of transport, heating and industry, you need about 40 square metres of solar panel per person. This is much smaller than the area of land to grow your food. So in Australia, 1 in every 3 houses has got a rooftop solar system. The typical new system is 8 to 10 kilowatts. It will cost you, for a 10 kilowatt system, about $7,000 US turnkey. You'll get your money back in about 3 or 4 years' time. It's the cheapest energy anyone will ever buy. And the grid remains completely stable, despite prognostications to the contrary. And by 2030, 2/3 of dwellings will have solar on the rooftop, as well as vast numbers of commercial buildings. Agri-solar is ever increasing. Putting sheep in among the solar panels keeps the grass down, and the farmer gets 2 income streams, one from hosting the solar farm, the second from running sheep. And the amount of grass that the area of land grows is not changed because the sheep get shelter from sun and wind, so does the grass, and the drip line along the bottom of the panels makes the grass grow really well. And this is, you can just go and see these things all over in Australia. You can have a high-density solar farm in arid areas. In the case of ASEAN, equatorial areas do not get tropical storms. So the black lines are tropical storms over the last 40 years. They do not come to the equator. So you can see that the Indonesian archipelago has vast areas of seascape which never see large waves, never see strong winds, and has the capacity to generate 2,000 times Indonesia's current electricity production. Indonesia and Malaysia, and by extension Singapore, have absolutely unlimited capacity to generate energy without chopping down any trees. So in Australia, which is the global solar pathfinder, because we are physically isolated and have more solar per person than any other country, the coal generators go up and down every day. What you see there is a graph over 24 hours. On the left is midnight, on the right is midnight. You can see the big blob of solar during the daytime. Green is wind, blue is hydro, orange is gas, black and brown are coal. The interesting thing is that the coal goes up and down by a factor of 2. So the coal drops down to half output in the middle of the day and then rises up to full output in the evening peak. Coal is providing most of the balancing for the solar and wind, and will continue to do so until it shuts down, which will be mostly gone by 2030. In 5 years' time, most of our coal will be gone. And guess what? The amount of gas was 12% about 4 years ago. Now it's 5%, and that is also on its way out. We do not need gas, we do not need coal, and Australia is showing that this is true. Facts on the ground. No matter what the fossil fuel industry thinks, this is what is happening. So what about energy storage? Well, it's batteries and pumped hydro. So Snowy 2.0 pumped hydro system under construction in Australia, 350 gigawatt hours. It's bigger than all of the utility batteries in the whole world put together. And it's equivalent to 7 million EVs. And this is a flat country, an economically small country with 27 million people. Just go out and build one of these. If you're in a big country, you build 10 of them. If you're in China, you build 50 of them. And guess what? The price of energy storage for Snowy 2.0 is $22 per kilowatt hour, the capital cost. And that is 12 times cheaper than the price of utility scale batteries in Australia. But almost all future pumped hydro will be off-river. That means water goes up and down between two small reservoirs not located near any river for the next 100 years. Almost no water required. And my team at ANU did a global atlas. We found 0.8 million off-river pumped hydro sites with 86 million gigawatt hours of combined storage, which is 2 trillion electric vehicles, or 250 EV batteries per person. We are absolutely not short of off-river pumped hydro systems. And if you go to any one of those 820,000 sites in our atlas, you'll be able to see this synthetic image. This is a 500 gigawatt hour site, sufficient for 1 million people or so when they're fully decarbonised. You can see it's a Class AA, which means a good quality site. You can see the upper and lower reservoirs, the tunnel route, and the dam wall down the bottom. Australia would need 2 of those to fully provide all the storage it needs. And you can see that we've got hundreds or thousands, 5,000 of them actually, all up and down the east coast where people live. And the area of land required to be flooded when Australia is fully decarbonised is about 4 square metres per person. That's the size of a large bed. And the amount of water for the initial infill and to replace evaporation is about 4 litres per person per day, which is 30 seconds of your morning shower. Land is not an issue, water is not an issue, because the same water goes up and down the hill for the next 100 years. What about ASEAN? Well, vast numbers of sites, really, really, really good sites. Every one of those dots is a site. ASEAN has tens of thousands of great sites just everywhere. So in the case of Singapore, obtaining electricity from Sumatra, well, there's great pumped hydro sites just in the west side of Sumatra, just a few tens or 20, 50 kilometres from where the solar power will be. You don't need to rely on batteries. There's no way you're going to build batteries up against pumped hydro, because pumped hydro is more than 10 times cheaper. You will build pumped hydro plus batteries to support the solar. It will not be batteries alone, unless you're nuts. This is a site in Sumatra. There's just hundreds of these sites in ASEAN. A height difference of 1,600 metres between top and bottom of the hill. This is just extraordinary by world standards, and ASEAN just abounds in these sites. ASEAN needs 8 of these sites when it is fully affluent and fully decarbonised. 8 of them, spread over all of the ASEAN countries, 1 per 100 million people. And the cost, about $10 per kilowatt hour is the capital cost. I mean, this is just so cheap compared with batteries, it's ludicrous. But you can do even better. This is in Malaysia, the Sarawak, state of Sarawak in Malaysia. This is 2 reservoirs, Bakun and Murum, separated by 12 kilometres of flat land that you could put an aqueduct in, then a short pressure tunnel, indicative cost of about $8 per kilowatt hour, which is 20, 30 times cheaper than batteries. And so Sarawak supplying Singapore with stabilised solar. You could put 100 gigawatts of solar floating on these 2 reservoirs with 4,000 gigawatt hours of storage. They can supply all of Singapore, all of half of Indonesia, all of Peninsular Malaysia, take your pick. And there's just many, many sites like this. So we're going to have a solar-dominated electricity system in ASEAN with a bit of wind in Vietnam and Philippines. Generation is going to triple when we electrify everything. Solar will dominate. We're going to need large amounts of overnight storage. And a combination of batteries and pumped hydro is the go. Batteries are cheaper for power, about half the price compared with pumped hydro, but about 15 or 20 or 30 times more expensive for energy. The combination of batteries plus pumped hydro gives you cheap power and cheap energy. That is the solution, the hybridisation of batteries and pumped hydro, completely off the shelf at any scale that you want, vastly abundant in ASEAN. Solved problem. And the notion is, the idea is you have a low power pumped hydro system with large energy storage, maybe 200, 300 hours of water in your reservoir. You trickle charge the batteries, which then take care of the evening peak. And you are trickle charged by the batteries, which harvest negatively priced electricity at high power, then trickle charge that electricity back into the pumped hydro over the next 20 hours. Nothing to invent, you just do it. This is what's happening in Australia. Go and have a look. These are the capital costs of batteries for 48-hour batteries on the left and 160-hour storage on the right. There's just no comparison. If you want energy storage, you go for pumped hydro. But you need also high power capacity for short-term storage, and that's batteries. Together, they solve the energy storage problem. So in summary, storage is a solved problem, nothing to invent. You just go out and do it. And when Singapore wants 6, 8, 10, 50 gigawatts of solar, you back it up with storage in Sumatra or in Sarawak or Thailand or wherever. Solved problem for storage, nothing to invent. And if you want to go to our Pumped Hydro Atlas, just click on that QR code. So thank you.
Thank you very much. Thank you for this very inspiring speech and opening up our minds. Are there questions to Prof. Blakers? Are you still calculating what you just learned? Huh?
Yeah.
And maybe introduce yourself and your affiliation.
Okay, yes, my name is Christoph Inglin. I'm also in Seas and Energetics, which is a solar company. So thanks, Andrew. Very compelling arguments you put there, very entertaining as well. I love the way you do it. Why is this not being recognized either politically or policy-wise? Why aren't we seeing this already being...
A very simple answer. You don't need much storage to get over 50%. Australia is at 43% renewables now. We've got a few extra gigawatts of batteries, no new pumped hydro yet, because coal is doing most of the balancing. Once you close most of your coal, then you've got to have a lot of storage, but you've got to start building the storage beforehand. So we've got 2 storage systems, 3 existing storage, pumped hydro storage systems, 2 under construction, including Snowy 2.0, which is bigger than all the batteries in the world put together, and another dozen under serious consideration. When you get up towards 50%, you suddenly discover pumped hydro storage. And I can say that we've been engaging intensively with most of the ASEAN countries right up to ministerial level, and I must say that there is a very strong appetite now at very senior levels within ASEAN to look seriously at off-river pumped hydro. Not damming any rivers, environmental costs are very low, but there's unlimited sites in ASEAN countries except Singapore and Brunei.
Are there any other questions? Yeah, please, do we have a microphone? And by the way, also talking about Australia, I had to, like last year, I had the chance to visit South Australia, the South Australia Power Grid Operations Centre. And this is the most extreme one in Australia anyway. So they will be the first major grid in the world which will not be running with synchronous generators anymore. It will be battery operated and power electronics operated grid. And that will happen in 2027 timeframe. The first major power grid in the world not using rotating generators anymore.
At times, for short periods of time now, rooftop solar provides all of Australia's, South Australia's electricity, just rooftop solar, even ignoring grid solar and wind.
Okay, last question.
Sorry, I have two questions. First question is that for solar, how much buffer capacity we have to add to ensure that there is a consistent, example, if we are taking 6 gigawatt hour from the solar power, then what should be the buffer capacity to make sure that every time we are having 6 gigawatt, even like whether the weather is like rainy season or cooler weather, right? So what buffer capacity we should put to ensure that we have all the time this consistent 6 gigawatt?
Okay, rule of thumb, for an affluent country like Australia, which is, when it's fully decarbonised, that means electrification of transport, heating and industry, you need about 50 gigawatt hours per million people, plus 2 gigawatts of power. So 2 gigawatts of power for 24 hours basically does all the storage you need. And if Singapore is importing 6 gigawatts of AC power from Sumatra or Sarawak or wherever, at 75% capacity factor, at a rough guess, you'd need 5 or 6 gigawatts of pumped hydro and 5 or 6 gigawatts of battery to do the job.
Okay, thank you very much. And thanks again to Prof. Blakers.